I sat down with Steve Kinney from Smart Vision Lights thinking we were going to talk about their new bar light. You know, what's new, what's cool. Instead, we ended up doing a full demo. He's swapping out lenses, adding filters, showing exactly how lighting changes when what the camera sees, not hypotheticals. You can see it change right there on the screen. Then he said something that completely stayed with me. Most engineers don't even think about lighting. They just throw something up and call it good. And that's why so many systems don't work as well as they should. So it made me wonder, how many production lines are underperforming just because no one spent 5 minutes thinking about how to light the part? That's what we get into today. If this is the kind of stuff you want more of, like the video and subscribe. That's what keeps this going and how I make a living doing this and paying my bills.
All right. I'm Steve Kinney, Director of Training, Compliance, and Technical Solutions for Smart Vision Lights.
Okay.
I've been with Smart Vision Lights now for 6 years, but in this industry doing imaging, starting with the camera companies, now on lighting since 1998.
1990.
1998.
98. Okay.
So you'll notice I'm a CVP instructor, as well as sitting, I'm vice chair of the imaging TSB on the A3.
Okay. Wonderful. Steve, over that time, you've seen a lot of innovation. You've seen a lot of new products. You've seen a lot of ways to make lives better in this industry. You guys have recently come out with a new product line, right?
Yes, several new
Okay,
products.
so talk to us about some of those new products.
Okay, well, starting with where we're at right now, and it's funny you mentioned that. This is a configurable version of our very popular LSR 300 bar lights. So bar lights are a popular form factor to start with. If I need general lighting and illumination, you usually either start with the bar or ring light if you don't know that I need something else. And the LSR has been a very popular version of this for us. And, you know, the 12-inch 300 millimeter is common in the industry. But what we've seen is we offer, users can say, this is what I need to do, but you know, we have different working distances and field of view. So we offer, like, for example, lens options. Do I want a narrow lens, a medium lens, or a wide lens to fit that field of view? Then more than that, depending on whether the object is shiny, matte, the kind of surface features, I might want a clear window to get maximum intensity light out there. Or if it's specular, I'm getting reflections, I might want a diffuse window to get a soft, cloudy day type of effect out of it, or even a linear polarizer. So you have all these options. We have a trial program where they can sign up through a distributor, get something and try it. But hey, if it's not right, they swap it out and you go through this process. We specialize that and done that for many years now. What you see in the LSR configurable is taking that to the next level. So now in this light, when you order a configurable, you get the main light, you get 3 lens sets that come with it, you get a cloudy diffuser, you get a clear diffuser, which is currently installed, you get a linear polarizer, and then of course the mounting hardware comes in. So there's instructions how to put it in and out, but what you can see is, we trade sides here, they've got the polarizer in. If we put one of our pins down here, you'll kind of see live, there's the pin. We actually have it sitting on the frosted defroster here, but it's okay. Wow. And if let's see if I can run my own demo here. If I toggle the lookup table, now you see a heat map.
Wow.
So you can see very readily, look at this, number one, the white background is filling in here. Yep. But if I remove it, let's go back so we can see the raw effect and kind of move that out for a second. Wow. What you see is, this is actually the wide angle lens. You see the intensity is not very high, but see how uniform it is over a big area. So for that pin, this is nice, and the pin is specular, so maybe it makes it even what I want. Probably not what I want. This might be a real part. I might want a faster shutter time, and I might want to have a more narrow version. Unfortunately, without my glasses, I can't read which of these are which very well. But if we slide one of the lens sets in here, let me find the right, wanting to make a point here. I know why we're fighting with the linear polarizer. Let's. So you just saw I didn't really want the polarizer for this discussion, and that easy to pop it out with a clear window.
That's amazing.
So now what you can see is, hey, we've got the light narrowed in here. Now it's hotter red in the middle, so it's more intense. But you see we maintain the uniformity much well outside of our object, but still in a big enough area. For something like the pin, this is near ideal. I'm very bright red in the middle. I'm covering the object, other than the fact that we're centering things by hand here, which we would never recommend. But you know, you fit it to the object and you're able to do that. So you're now able to quickly adjust kind of which attributes I want. You'll see if I put the other lens set, now see it got dimmer, but a little more uniform out to here. You don't have red to green to yellow. We just got green to blue, showing more uniformity. If we really wanted to, in this demo, we can actually do a comparison view, put them side by side, toggle the lookup table, capture a reference. Now there's our reference, and again, we'll go back just to show your users. Here we can go back to our other narrow lens, and you'll see there it changes.
Got it.
So you're able to do this. You'll notice if we toggle lookup back to visible, notice we see that glare along there. That's why we have the linear polarizer. So things like glare are often fixed with linear polarizers. So we'll put the linear polarizer back in here for a second.
Wow.
And you notice, so that's cross-reference. There's a polarizer on the light as the transmitter. On the receiver on the camera, we have a corresponding rotating filter on there. So you'll notice as we rotate the filter, it gets darker because polarizers take a lot of light, but notice the glare, how flat that is.
Absolutely.
That's because it's rejecting the light that's coming off the surface for the glare and letting the other wave of light off the back come floating to us, and you're able to block it. But that's why it's really important to be able, for your users, to be able to adjust the field of view, because now I need as much light as possible on there, make it bright enough to use the polarizer and get the effect that we want. It's not just about diffusion and other things. It's, hey, I need to use this filter as well.
Yeah. So, Steve, what's the biggest mistake that engineers make when setting up lighting for vision systems?
Well, the starting point with that, and we were laughing about that earlier, the starting point of that is usually they don't think to set up the lighting. You know, we see people, oh, the ambient light is good enough. Or, no, I got a light, but I just kind of put this low in. I got an industrial light or a workbench light and put down there. Hey, you see the importance here in this demo of focusing the light. Light is, you got to think about light. Where did it come from? How did it get to the object? How did it get in the camera? And then within that, what kind of light was it? Because for the same object, I'll get a different effect with a dome light versus a ring light versus a coaxial half mirror type of light. And most people, A, don't know that and realize that, and B, they don't even think that I need to control that. So the starting point is finding a company like Smart Vision Lights. We have full application support on the front end. We're doing training in our facility if you want to sign up for free training. I'm teaching at the show here. We teach certified vision professional classes. I'm one of the instructors. There's many other instructors.
What don't you do, Steve?
A little of everything. I'm a personal guy. I've been doing this quite a while, but you know, we want to teach them and make it easy so they're aware, and then even awareness is the real key, because then if they come and they're not right, they at least know what questions they're asking, what they're looking at, and we can help them. Yeah. Or if they know nothing, at least they can come and ask for the help. And that's the single biggest. Once we get them on the right track, hey, these lights are easy to mount. You notice there's T-nut mounting in almost all my lights. Most of my lights are metal housing and either extruded or a cast housing. Smart Vision Lights' claim to fame is we put the built-in controller in the light. So talk about ease of use. So this little M12x5 has been constant pinout for us in the 17 years of our existence. And there's power, ground, an NPN trigger, PNP trigger.
Wow.
So no matter what I'm interfacing this light, whether it's positive or negative logic, it interfaces, plugs and plays. If I don't want to trigger, I just tie those to the 24 volts and don't use those lines. There's also the fifth pin gives me dimming or overdrive mode control. So the same light can be used in a continuous fashion or overdrive to get about 3.5 times more light out of it for free. And if you need to synchronize it with the camera, you just take the appropriate trigger, wire it to the camera, and use it.
That's awesome.
So that's found in probably 90% of my products. The only time we don't build that kind of controller in is when we're doing higher end products where we have maybe 4 channels for photometric stereo or something. It becomes too much to build into a compact light. At that point, we move to an external DIN kind of device. But those kind of things are often overlooked as well by our users. They think, oh, all these lights are the same. If I buy from this guy, that guy, it's not. We have to think through those details. The other thing that your users probably don't recognize about LED lighting compared to us and the others, the other benefit of that built-in controller is it gives constant current drive to the LEDs. Almost all my other competitors prefer to be constant voltage drive. Constant voltage is nice because, hey, there's only 2 pins, so the LED is kind of like a light bulb. Make the 2 connections and it comes on. So in one way, that sounds simple. I just hook up a 24 volt supply, the light comes on. Oh, now you want to wire it to the camera. Oh, go buy this extra piece over here that allows you to take a trigger in, then interrupts that signal and does it. Oh, you want to dim, all those things. But more than that, the LED itself as a device is a semiconductor junction. The amount of photons coming off that junction, 1 millimeter dies are typical here. The amount of photons coming off a 1 millimeter die is proportional to the current running through it.
Wow.
And an electron hits that silicon, knocks a photon free, and makes light. If I'm voltage driven, an LED is a diode, so the ambient temperature raises, the forward voltage on that diode raises. I'm voltage driven, the source driving it did not raise, so the current goes down.
Got it.
Current goes down, the light goes down, you get variations. So basically what we're offering, not only the ease of use for triggering and all the other functions that are in that controller, but the fact that it's constant current means we're more stable than the other ones. And my competitors don't like to do that because if I make it constant current and I don't build the controller in, which is an art in and of itself, then I have to do it externally. And now the light is kind of like a light bulb. I need an external controller. But constant current lights, these things run at maybe 5 to 8 volts kind of drive. And they're not fixed voltage because, again, the current level and the voltage drive it changes. So if now an end user has a constant current system with an external controller and they separate it, and someone doesn't know what that is, and they plug it into 24 volts, that light goes poof, burns out in less than 1/10 of a second, right? And so we give the best of all worlds there. You get the kind of drive you want, but you get the ease of interfacing, just wire, power, and go as if it's constant voltage, and the other functions come for free on there.
Steve, I've got 2 more questions for you. The first one is, what is the impact that smart vision lights and lighting for vision in general has on production and the humans that are running production?
That's a very good question. In general, I'm a proponent and sitting on the A3 board and stuff. The first thing we tell you is this whole thing about robots took my job. It's not true. The numbers don't show it. We want to be very careful about treating that sensitively. But the reason it's not true, all the companies here, we don't want to go automate just to replace a job, right? We want to do the things that are hard to do, have to be done at a numerical computerized level, not by human eyesight, dirty, dangerous, all those things. Robots, automation, lighting, machine vision, all should be used to enhance the worker's performance, not replace that worker.
Absolutely.
Right? So that's kind of the starting point for us. And when you look at all these lights are aimed at improving your consistency, the output. Again, controlling the lighting and not just using the ambient is the starting place to getting a better result. Better result is better for the efficiency of the company, those workers, and everyone involved. And what it really is allowing you to do is leverage the power of that worker through these as tools to get more output.
Yep.
The analogy I make for people is, if you think robots or automation took your job, then let's make an analogy to roofing on your house.
Yeah.
And if you go have a roof today, and it's amazing to me, I had someone recently quoted a roof, $15K.
Yeah.
When I was growing up, even in the 70s and 80s, this used to be 30, 40, 50K. And the reason it's cheaper is not that the labor is cheaper or anything here. The reason it's cheaper is they show up with 3 or 4 guys on a crew and not 12 guys on a crew. They have pneumatic air tools. They have all these neat little battery tools, and they go up there and they not only do the job faster and more efficiently, they do it better. There's no more, oh, I bent the nail, just pound it over.
Yep.
It's bap, 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 and fast. So if you think the robot took your job and you want to create jobs, and the next time you need a roof, you just go pay $50 or $60,000. You have 12 guys show up and deal with hammers and no air tools. You tell me if you're any better, or those guys think their business is better, right?
Absolutely.
It is no different with automation.
Agreed.
That's how we seek to improve
Agreed.
everybody's life.
I was told earlier this year that automation, AI and robotics are not going to take jobs from humans, but people who adopt that technology will. What do you think what do you think of that statement?
I disagree, and the numbers, again, don't show that. I mean, it's hard in these interviews to go backwards and show you those things. But, I disagree with that. What people forget, if we look at the economy last week, and maybe last week's not good because we're kind of floating around, but if you look at the economy in a week where, say, 100,000 jobs were created,
Yeah.
do you think that no one lost their job because 100,000?
Right.
What we're talking about is the big picture. When you say, and this is where, for me personally, I think we have to change the dialogue. I don't like pitting one against the other, or hearing that the robot took my job.
Yeah.
You will find someone, the longshoremen's strike recently was a good example. You will find someone that says, my job is being taken by automation, and there will be examples of that. But if you look at the picture of a whole, production, GDP as a nation, that doesn't hold up. This little segment lost it, but for every job lost there, 2 were created out here, and those 2 jobs are cleaner, better paying, higher end jobs than the job that was taken. That's absolutely true across the board now. And when we talk about onshoring and a manufacturing renaissance in America right now, you got to understand manufacturing. Manufacturing is about doing things at high efficiency to make the best product, highest quality at the lowest cost. And automation helps us do that.
Absolutely.
And giving the workers, just like the roofers having air tools, giving the workers automation and robotics to enhance their performance is the only way that we compete in the world.
I love it. Steve, this has been a fun conversation. Thank you.
Thank you very much for having me.
All right, everyone, that's it. I appreciate you watching. Hit the like button, hit subscribe, and I'll keep showing up with more of these kinds of videos. Got questions or comments? Drop them below, and I promise I'll respond. That's a deal.